We are now recording. Okay. Now we'll get started. Let me first, well, I'll just go by this. This is Physics 112, a brand new course. Never been taught here before. I've never taught it before. It's was developed or picked out or something for the sonography program that y'all are in. Okay? Supposedly this will give you the physics you need to be able to understand the future courses you do in, it's called DMS, is that right? Okay. So we're going to learn it together. Okay. I know the physics, but I don't know exactly what pacing to do and that kind of stuff. We'll get to that. Okay? It's a 2-credit hour course. We don't have a lab with it, just be 4 to 6 because it's a mini-term course, 2 nights a week, Mondays and Wednesdays. Okay, and that's what it says there. And I'll have to change this. I guess it's still Building K. I'm not familiar. That's 103, right? So let me change this to 103 and 103. Okay. All right. My name is Charles Fowler. I'm the instructor for the course. My office is 4 days a week. It's on Bessemer campus. It's an A265. This is my phone number there, and here's my email address wherever I am. Okay? This is really squiggly seeming to me. I don't know if it's a projector or if it's my computer connection to projector. I don't know what the reason is. They're both really secure. Okay, but does it seem wiggly to you? Okay, sorry about that. I don't know. Maybe we'll find another room. I don't know. So anyway, I'm on Bessemer campus Monday through Thursday. Okay, on my office on the West campus across the way, orientation here, across the street that way is I'm there on Fridays in B122, and the number in that room is 9296409. My number on Bessemer 9293449. Email's the same on either. So, what are my office hours? On Mondays, 7:45 in the morning until 9:30. At 9:30, I have a calculus class that goes till 11:10. So I get back to the office around 11:15, and I'm there until 2. At 2 o'clock, I've got a class on the Bessemer campus that's 2 to 3:15. And as soon as that class is over with, I have to book it over here as fast as possible to get here. So if I'm running a little late someday, that could mean that I was giving a test and the students were slow finishing, or there was a train that held me up, because there's no way that I found to get from Bessemer to Birmingham without crossing track somewhere, okay? I'm sure there must be a way somewhere, but it's going to be way out of the way. So that's why I don't get here till right at 4 o'clock, okay? Hopefully we'll get here a little earlier. So after my 2 o'clock office hours there, I'm in class and then booking it over here. On Tuesdays, got 2 classes in the morning, 8 and 9:30. 9:30 classes over at 10:45, and then I have another class that starts at 1:15. So I'm in the office from 10:45 to 1:15. And by the way, if you haven't noticed, I usually bring my lunch. I eat in the office, so you can contact me in the office just about any time. Okay, so that's why I haven't set aside lunch hours yet here. Wednesdays just like Mondays, and Thursdays just like Tuesdays. The reason I don't have any office hours after 1:15, it's also a mini-term class. It's a physical science class with a lab. It's a 3-hour lecture, 2-hour lab, so that means it's 4.5 hours a day, both days, Tuesday and Thursday. So I'm in class then from 1:15 until 5:45. And after that, I'm getting ready to get home, okay? So then on Fridays, I'm over here on the Birmingham West campus from 7:45 in the morning until 11:45, most Fridays. Now, I'll go on and let you know this. I have a mild form of leukemia. It's CLL. Y'all are medical professionals. You may know chronic lymphocytic leukemia. I've had it since 1991, so it's not a huge deal. But for the first 17 years, the treatment was worse than the cure. So, I mean, the disease, the treatment was worse than the disease. So the doctor did absolutely nothing, but we slowly watched the white cell counts come up. Finally, they got so high, he said we need to do something. So I went through 4 rounds of pretty mild chemotherapy. It was fludarabine and cytoxin. There was supposed to be a third one, but the doctor didn't like it because he had had some close calls from 2 patients, almost going into anaphylactic shock and that kind of stuff. So he said it's probably not going to do yours any good anyway. So he left off the monoclonal antibody. Well, that really knocked the counts way down from 475,000 to about 10,000. Okay, so really effective, except it didn't wipe out the disease. It just knocked the counts down. So for the next several years, the counts just slowly started coming back up. That old doctor retired, got the new doctor. He loved Rituxan, okay, the monoclonal antibody. So when the counts were climbing on me, then he put me on just Rituxan. And it controlled the counts, but it still didn't knock out the disease. And after a while, it wasn't doing as good a job. And there was a new one that came out, ofatumumab or something like that. R0 was the brand name. It did about the same as Rituxan, only after a while it wasn't even doing as well as that. So in February, just last month, he started me on a new one, and it's been extraordinarily effective. It took my counts, I was 128,600 down to 1,100 in one treatment, okay? So it's been very good. Unfortunately, it also wiped out red blood cells, not at that extent, and platelets it really bombed, and neutrophils it really wiped them out pretty badly too. But they have come back. I've had 2 more treatments since that first one, and things are slowly coming back up, and I'm doing better with it, except I have a treatment Friday. So that's what I was getting to. I won't be in the office on either campus on Friday, okay? Now I don't see my office. This is a new format that they have us do now, and it doesn't show where the office is. So I'm going to have to put that in, but I think I just said it. Yeah, there it is. There it is. Yeah. I thought it had to be there somewhere. Oh, and here's the thing. Here's one other reason I want to say this. My voicemail on my regular phone, this one, 929-3449, is very sporadic. Sometimes I get the messages, most of the time I do not. So don't bother leaving me a message. So if you're trying to call me, call during office hours. If I don't answer the phone, don't bother leaving a message. Wait a few minutes, call back as long as it's within the office hours. Okay? And not Friday, because I'm not going to be there. Okay. Now, on Friday, I'm sure this voicemail works a lot better, but that's not my office. It's the office I use on Fridays. It's a grant coordinator's office. She's part-time, so she's only here like Monday through Thursday. She's not here on Fridays, so that's why I use her office. But if you leave a voicemail there, it'll go to her, not me, okay? And I don't have any way to get it. So you can call when I'm there, but if you don't get my answer, don't send a voice message. Just wait a few minutes and call back. Unless I told you I'm not going to be there. Okay. Now, that's the stuff about me. Let's get to the course description. That's more important to the course. Okay? Can y'all see that? I don't know if you can read it because it's, again, a pretty lousy. It's just wiggling like crazy. I'll read it to you then. This course introduces the student to the basic principles of physics with an emphasis on electricity and magnetism. The course is designed to provide the student with not only the basic knowledge of electricity and magnetism, but also an understanding of real-world applications. Okay? That's why the name of the book is Applied Physics Applications. That's the emphasis here. Okay? Okay. To prepare the student to understand electricity and magnetism, though, you have to have some of the terminology from the earlier chapters. So additional topics include forces. Okay, that's where we begin here, folks. If I thought I saw at least one book, yeah. Okay, when you get your book, I'll just do the table of contents here. Chapter 5 is forces. Okay? And there's 6 sections there. I'm pretty sure we're not going to do all 6 sections. Okay? And here's why. Well, we'll get to that in a minute. Okay? Work. Work, comma, energy. Flip over here, chapter 8, work and energy. There's 5 sections there. We probably won't do all 5 of those. We'll see. Okay? Power. Oh, that's also there too. That's in chapter 8. Work, energy, and power are all in chapter 8. So I know we'll do those first 3 sections. So those are the ones. Sound. Okay, sound is down here in chapter 16. Wave motions and sound. Okay? We may skip some of the wave stuff and just go right to sound. But we got to do some wave stuff so you'll know what we're talking about with sound. Okay? The atomic nature of matter. The closest I can find there is chapter 12. And by the time we get there, hopefully I will have found the most pertinent parts of that. Okay? So that's the background stuff you need. And then topics in electricity and magnetism include electrical forces and fields. So that's why you needed to know about forces, because we're going to talk about them here. Well, basic electricity starts in chapter 17. Okay, and electric fields are in 17.4, and I believe that's where forces are too. They just don't have a section for that. Currents is in several places, but you see also here it says currents in electrical circuits. Electrical circuits, the simple circuits is 17.5. Series circuits are in 17.7. Parallel circuits in 17.8, and compound circuits in 17.9. I don't know if you really need that. Now, do any of you have a real gut feeling of what you need as far as circuitry and what you're going into? Or are you brand new to it as well as I am? Okay. So probably we'll just go with simple circuits. Okay? Maybe a little of the other. Okay? So currents and circuits, those go together. Then magnetic forces and fields, that's down in chapter 18. Okay? And 18.1 is Introduction to Magnetism and Magnetic Effects of Current. That's 18.2. And magnetic forces on moving charged particles. I think that may have relevance to what you are doing. So, getting there. Okay? Capacitance. That's down in alternating current electricity. Okay? There's AC power here, which I think may be important in 19.2. Capacitance is 19.5. But if you move on a little bit further, electromagnetic induction, okay? Inductance is in 19.3. And inductance and resistance in series, I'm not sure you really need that, but if we do, we'll cover that, 19.4, and like I said, capacitance is 19.5. So that's chapter 19, and then it says transformers, okay? Okay, I'm sorry. I found it, and I've included it, I just don't remember which one that's in. I believe it's under inductance as well, okay? So, yeah, I just got the book last week and got a chance to compare this with the course description today, and I tried to cover everything listed here, find the sections that was here. I may have some of them wrong, but I've got them all covered. Okay, so what does that boil down to? Chapters 5, 8, 12, 16, 17, 18, and 19. That's 7 chapters in 8 weeks. Okay? All right. Now, that means we got to do about a chapter a week. Today, not going to get very much done. So basically, next week is our week 1. And we'll do forces. And like I said, we'll start at the beginning of chapter 5 and do as much as we can in the 4 hours we've got on 5. When we finish that, then I'll make out a test for you. And if it's okay with you, what do you feel about take-home tests? Oh, you can handle it? Oh, That took a load off my mind. I was afraid you were going to insist we have in-class tests. Okay, so we'll go with take-home test. And you see, that does several things. It doesn't take up class time to do. And, frankly, to me, the more important thing in physics is not memorization. The physics is how to use material you can look up. If you were working for me, I don't want you memorizing formulas. It's, oh, I know how to do that. Yeah. I want you looking up, make sure you got the right formula, and then you apply it properly. So I think what you need out of physics, my guess, I don't know, the first time I've done this, is for you to be able to look it up, see how to solve a problem, and solve it correctly. So you're okay with that? Oh, good. All right. So we'll do about a chapter a week. I'll get as much covered in that subject as I can. Now, the only bad news to that, I won't know how far we're going to cover until the second day of the Wednesday. So I can't guarantee I'll have the test ready for you because I don't know how much we're going to cover. So what I'll probably do is have the test for the previous week's chapter, give it to you Monday, take home, and you have a week to do it, and we'll go on with the next chapter material. How does that sound for a game plan? That's fine. Okay, so we'll do that. All right, as far as I know, because they didn't have anything but this on the courses, course description. Sure is there. Okay. The prerequisites, whatever is required by your program, and I think you have it. Okay. Co-requisites, none. Specifically, math levels. From what I understood from Dr. Marable, she's the chair of the the Health Services program here. She's associate dean. I believe Math 100, you've all had at least that level of math. Is that right? That'll be plenty, I think, for anything we do. Okay, this is not a math-intensive. You'll be doing lots of problems, but it's going to be fairly simple math. And you'll have your books open. You can do whatever. Okay, so the textbook. I put it as required because it was on the syllabus that way. So if you can do it without it, more power to you. But I would suggest having it. Applied Physics. The authors are Dale Ewan, Neil Schurter, and P. Eric Gunderson. Okay? And it's Applied Physics, 11th edition, right there. And I forgot to put down who the publisher was. It's Pearson. I probably should put that in there. I won't do it now, but I'll try to remember to. Students are expected to bring the text to class because I'll teach from the text. So that'll help you follow along if you want to. That's up to you. You're adults, okay? And paper, because we will be working problems, or at least I always do in most physics classes. It's the first time I've taught this one. And pencil, if you prefer ink, that's up to you. I don't care. To class each meeting. Calculators are permitted. We have to put that on for our lower level math classes, whether we permit them or not. This one, for sure, you can use any calculator you want to. Are y'all familiar with Blackboard? You are? Everybody? Anyone who's not? Feel free to say if you're not familiar with Blackboard. Everybody is. Okay, so I won't go into that too much. I think it's basically they overstate this pretty bad. All courses must use Blackboard to gain access to vital course information such as the syllabus, handouts, PowerPoint shows, activities, assignments, announcements, and so forth. Okay? Now, the syllabus is already out there. I've got to go change it because we changed rooms. And I'll probably also put in the publisher and just a few minor things like that. But it's out there now. Okay? I'm sure you're going to read it every week too, aren't you? Yes, of course you will. Okay. Handouts. Most of the time, if you have a handout, I'll hand it out to you. So I don't usually put those on Blackboard. The PowerPoint shows. I've already got them there. They're there right now. Now, y'all said you're familiar with Blackboard. When I went to pull up the Blackboard for this course, parts of it don't look anything like I do on normal. I usually have, when you pull it up, this course, most of the time there's a little block up here in the upper left corner with a bunch of tabs. In this course, it goes almost the whole screen. I don't usually have that many tabs. Usually I put under content everything you need. This doesn't even have content, okay? It did have one tab for syllabus, so I put your syllabus there. You'll find syllabus there. And then somewhere else down the way, somewhere about right in here, say, was something that said stuff like course handouts and more, or course, was it information or more, something like that. And in that one, I put everything else. I put all the PowerPoints. I put the locator cards, which I'm going to show next. That's all I've got so far is that. And the link to YouTube. Because like I said, when I finished the class, I uploaded the whole thing, shebang, to YouTube, and then under that place. Now, if you can't find it, it's something that says course, handouts, and more, or something like that. Find the thing closest to that under Blackboard. Like I said, this is not the Blackboard I usually, or someone specialized this one, and they put all this mess in there. I guess it's what the nurses use, but I don't know. Okay. Any of you from the nursing program here? Not. Okay. ER? No? Okay. All right. Okay. Well, anyway, if you can't find it, I'll show it to you sometime. Okay. So PowerPoint are out there right now. But guess what? I'm going to teach from the PowerPoint. So when we get to the material that we're covering on it, then you'll have not just the PowerPoint there passive, just static. You'll have me talking, and the reason I wanted to use this computer is it has an ionizing pen, and I don't know if it'll write here. No, I don't think it will on this screen. But when I get PowerPoint up, I can write on the screen. So if I'm solving a problem, you'll see me solve the problem. So all that will be there. Okay? That's why I couldn't use the smartboard, because it wouldn't record it. Okay? Activities, sometimes they put college activities there. We're not going to have any activities except coming to class and doing the physics, okay? Assignments, if there are some, for instance, say at the end of a chapter, let me see, we're starting in chapter, what is it, 5? Okay, let's just find chapter 5. And again, this is the first time I've used this book, so I don't know for sure. There are things that you can get ready for your test with. Review questions at the end of the chapter. There's review problems at the end of the chapter. Most of those review problems, I'm assuming, and again, I'm assuming, there's problems scattered throughout the text, and we'll work some of those, if not all of those, on the slideshow. Okay? So you'll have that there. So usually I'll say, okay, you can use these review questions, those review problems to get ready for the test. That will be on YouTube. I'm not going to type them out someplace special and say these are your assignments. Okay, announcements, again, those come mostly from the school. And then they have this, what I consider as sort of a dumb sentence here. Failure to use Blackboard will severely damage your ability to pass the course. That's just not true. Maybe in some courses they just teach with Blackboard. To me, Blackboard's a tool. It's not the guiding light, So if I were writing this, but they don't let us change it, I'd say the proper use of Blackboard could greatly enhance your ability to do well in the course. It's a much more positive statement, and I think closer to reality. Is this in the way of anybody? It's not. Okay. All right. And then students should always check the Blackboard announcement page and task pages prior to coming to class. I kind of resent that one too. Okay, and the reason is, the only reason I could think of that is comma in case the instructor has canceled class. And I'll tell you now, unless something major happens, I'm going to be here every day I possibly can. If I know if something's coming up, I'm going to let you know ahead of time. Now, sure, when I had that first round of chemo on this drug, I was so fatigued one day, I just couldn't make it to class. I gotten up and showered, ate breakfast, dressed and everything. I went downstairs. I collapsed on the sofa. I said, I don't think I can drive. I feel that exhausted. And my wife said, don't get back. I went up. I never sleep in the daytime. I can't usually sleep in the daytime. Went up, crawled into bed, slept till noon. I mean, just out like a light. So hopefully that's not going to happen. I've had 2 more rounds. They didn't affect me that badly, so I don't think that's going to happen. But if it did, I'll put that out there, okay? But if I get stuck by a train, I ain't no way I can get it on Blackboard, to get you the information. So hang on. I'll be here if at all possible. nothing else, I'll get the phone number for the office here and call them and let them know if I can't be here. All right, professional competencies and objectives. Okay, scroll this up. Core student learning outcomes. Students will solve problems dealing with forces. Chapter 5. Students will solve problems dealing with work and energy and power, I should say. Chapter 8. Students will demonstrate an understanding of the atomic nature of matter. That was chapter 12. This isn't the same order that was in the course description, but it's covering it all. Students will demonstrate an understanding of sound. That was chapter 16. Students will demonstrate, solve problems dealing with circuits, currents and circuits. That was chapter 17. Students will demonstrate an understanding of magnetic forces and fields. Chapter 18. And students will demonstrate an understanding of capacitance, electromagnetic induction, and transformers. That was chapter 19. Okay. So that was from the course description. I adapted it for your student learning outcomes, and this is. So what are we going to do? Have a test at the end of each one of those. Now here's my guess. My guess is your chapter 19 test will be your final exam. It will not be comprehensive unless we really buzz through this stuff really well, which I can imagine. Never do that. I'm too slow. Okay, so my guess, chapter 19 test will be the final exam. I put it up there just in case we finish early and then we have a comprehensive. I don't think it's going to happen. My guess is, especially since I can't make out the test till I see how far we covered. So my guess is that would be that week. I will have to have it ready like last day to give you, and then you get it back. Okay. Evaluation and assessment. The following list, they have all this in here. It seems dumb to have that first statement there, but they have it there. A chapter test will be given at the end of each chapter. The lowest chapter test score may be dropped. In fact, probably will be dropped. The average of the remaining chapter tests will determine your grade for the course. Pretty straightforward. Okay? I decided not to give you a research paper to do. Are y'all okay with that? Yeah. Oh! I was afraid y'all going to be mad at me again. Okay? And you know, I decided not to make you turn in homework. Y'all okay with that too? Oh, good. Okay. Okay, y'all are easy. I like this class. Okay. And then once we've averaged those grades, everything in the 90s are A's, 80s are B's, 70s are C's, don't even bother going down there. Those are passing scores. These at Lawson are not. D is not failing, but neither is it passing. Okay? Unless your program allows D's. I don't know if they do or not. I doubt it. Else certainly not. Okay? So nothing, hopefully, very new there. And then they made me put this in. I mean, this was in their thing. It's a really dumb statement there. Obviously not mathematicians who wrote this. Instructor rounds grades upward. That's not true. A round grade normally. Okay? But what it's saying, never downwards, that's not quite true either. But here's the example. And they made this example too. For example, a 79.5 rounds up to an 80. A 79.4 rounds down to a 79. So those two statements are not, but they don't let me change them. But yeah, this is what I do. I round normally. If it's 0.5 or higher, you go to the next number. If it's 0.4 or lower, you drop. But actually, well, that would be averages. Okay. All right. Attendance. I think you've probably seen all that, but they do it in gory detail. Try to be here every day. I'm going to try to be here every day. If you have to miss, I'm recording it anyway. And now, let me say this. We have had occasions when our whole computer system goes down. When that happens, can't handle it, okay? So those days we may not. That doesn't happen often. Hopefully it won't happen, okay? And then this shows what to do if you are going to need. Email me if necessary. And by the way, someone else besides you did email me. Was it you? Oh, you did too. You did, okay. Sorry I didn't respond to it. I didn't see it until when I was trying to get things together. And I never had a chance to get back because I've been in class most of the day today. Okay. Check Blackboard announcements in task, whatever that means, okay. Consult the class calendar on Blackboard, see what you missed. We've just gone over what we're going to do every week, so you can do this. review material on Blackboard, and in your textbook, the textbook. I'm not going to put too much on Blackboard, except through YouTube. So it's all out there through Blackboard on YouTube. So I guess that is legitimate. Okay. Return the next class ready to advance with your class. Oh, that sounds so positive. Okay. Withdrawals, basically, what this comes down to, if you look like you're, and I don't foresee this happening if you come to class and do your work, and I think y'all are go-getters, so I don't think there's going to be a problem there. But if it looks like there's no way you're not going to make a C or higher, that you're going to make a D or an F in the course, which I can't foresee, but if it does look that way, far better to withdraw than it is to get a D or an F is going to hurt your grade point average. A withdrawal does not hurt your grade point average. Now, there's financial aid. If you're on financial aid, there may be those considerations to make, but guess what? Most of those financial aid packages will allow you to repeat the class once, not twice. Whether you made a D, an F, or a withdrawal, you got to repeat it, right? So it doesn't matter whether, which it is, you're going to have to repeat. They'll pay for it one repeat, but not two, no matter how it happened. And a D and F is going to hurt your grade point average, a withdrawal is not. It's a duh, withdrawal is always, in my mind, better than a D or an F. Okay? Makeup work. Okay? I give you the test, say on a Monday, and try to have it back to me by the next Monday. Okay? I want you to have a whole week to work on it for two reasons. Number one, you always have another class meeting to ask me questions. Okay, now, what are questions? What do you mean by this? Okay, yeah, that's legitimate. How do you do this? Wait a minute. You're the one taking the test, not me. Okay. But here's the deal. If it's like an example or a problem in the book, I'll work anything from the book as long as it's not identically the same question, which I don't think it will be. But I won't say, oh, here's how you do that problem, and then you or everybody else gets to hear how you work the problem. You all make A's. Okay. Well, I don't mind you making A's, but I want you to do the work. That's the point. Okay. Does that make sense? Okay. All right. So makeup work really doesn't make a lot of sense if you have everything in. Oh, and the second reason I give you a week, you always have a weekend. Because sometimes y'all are working like crazy during the week, and the only time you have to work on it is the weekend. Okay. But always look at it so you can ask questions that next Wednesday. Okay, lateness policy. Get here when you can. I know life gets in the way. I get here when I can. Okay. Now, they have this whole section on academic integrity. Okay. Y'all know this. Is there any reason for me to read all this? Please say no. Okay, excellent. Okay, cheating, don't do it. Okay. Plagiarism, taking tests, it's really hard to plagiarize. I'm not having you write any papers. Yeah. Go for it. Cheating, don't do it. Okay. Professional decorum, you know what to do. It's all written here. Read this. Yeah, I'm not going to take time on it. Course concerns. If you do have a problem with me or how I teach the course or whatever, come see me. I'm not a retaliatory type person. I'm 67 years old. I'm not going to be here that much longer. Let me know. I'll change. I'll do whatever I can. So see me first. If you feel like you're unsuccessful there, I'm the chairperson, but you can see Dr. Wilson. She's also a chairperson of natural sciences. I'm chairperson of math. You can talk with her. You can see Dr. Marable. She's chair of over here. You can see Dr. Pruitt. He's my boss on that side of campus. So see any of those folks. After that, if you aren't satisfied there, then you can go all the way up, and there's all these links, that you can go to and make formal complaints. The deans and the vice presidents and presidents get involved in whatever. We want to know if you have problems. Okay. Statements on discrimination and harassment. Okay. Let me summarize this. We don't condone it. We don't tolerate it. We deal with it. Please let us know if you think it's happening. Now, I've been here on this, I think is the beginning of, or in the middle of my 21st year teaching, not at Lawson necessarily, but Bessemer State Tech and or Lawson, the Bessemer campus or this one. And I have seen basically none that I could tell. Okay? Now, that doesn't mean it hasn't happened. It means I haven't seen it. Because people doing it tend not to do it in front of faculty members. Okay? They tend to do it behind. So if you see or sense or think there's any possibility that people are being discriminated, harassed, now I count in this bullied, or anything else like that, please let us know. We'll investigate, we'll be fair about it, but we will deal with it because we don't want it happening on our campus. Okay? I don't think you probably will see much of that either, but let us know if you do. Now, Americans with Disabilities. If you may have noticed when I was calling the roll, I had to, what was that? Yeah, that's because I'm hard of hearing. So I kind of understand. I'm old, decrepit, falling apart. So if you have any type of disability, please follow these guidelines. You can let me know. I'm going to turn around and let our person on this campus is Mrs. Janine McCoy Jones. Actually, she's across on the west campus, but that's on the Birmingham campus. And she will get her the documentation. She'll let me know what we need to do. Okay? On the Bessemer campus, it's Dr. Renee Herndon, and she's over all of it. Okay? Now, this is from the college calendar. It's mostly for full-time courses. Not going to be much different for mini-term, except the one thing, I'll say this. The final exams for the full-time course are Monday through Friday. For us, we have class that Monday the 30th. We have the final exam Wednesday, what would that be, the 2nd. Okay, so that's one sort of change there. It may be the last day to withdraw is a little bit later than this, but there is a deadline. And it can't be much later because that's like 1 week before class is over. So I don't think it can be much later than that. Okay? All right. And then at the end of the syllabus, and I'll try to get it correct to those little things that we found that were wrong. The end of that, if you will either type your name in here and email me this page or print off the page, write your name and give it to me, that indicates you've read the syllabus, you understand it. Any questions on the syllabus right now? Okay, sorry this is taking way too long and probably not that good of information, but I did want to go over how we were going to do it. I do want to save that. Okay. All right, let's go to this. This is my locator card is what they call it here. It's sort of a dumb name. Again, this is spring 2018, this term, second mini-term. These were not my orders, first mini-term, the second. My name again, my phone number, the number on Friday, 929-6409. Don't leave me voicemails at either one. My email address, and usually I'm department chair of mathematics, but I'm credentialed to teach physics and physical science, and I do teach both of those. Our usual physics instructor is maxed out the number of classes he can teach. Otherwise, he probably would have been the one teaching this, but he's actually more hours than he's supposed to have. Okay, this is not going to get it all, but it'll get most of it. Okay? This just repeats what I said earlier. I'm usually on campus by 7:45, all 5 mornings of the week, Monday through Thursday on Bessemer, Friday here on Birmingham. My Monday, Wednesday class, 8 o'clock class, did not make this time, so I have office hours from 7:45 until 9:30 on Mondays and Wednesdays. Then I'm in class, it's a calculus class. It's a little bit longer than most classes because it's a 4-hour class from 9:30 to 11:10. So I'm back in the office about 11:15. My office on the Birmingham Bessemer campus is A265. I usually eat lunch between 12 and 1 or somewhere close to that. But like I said, I bring in my lunch. I eat in the office, so I'm available then too. And then, again, office hours between 1 and 2. 2 o'clock, I have a Math 98 class, or developmental algebra class. And then when I get out of that, there's 15 minutes. I'm getting my stuff together, driving to Birmingham, and then we start at 4. We go till 6, and I'm off campus at 6. Tuesdays and Thursdays are the same. I have at 8 o'clock pre-calculus algebra, 9:30 pre-calculus trig. Then I'm off in the office from 10:45 until lunch at 12, and till 1. I'm in the office, okay. But then technically office advising again from 1 to 1:15. That's when the physical science class starts. The class goes technically 1:15 to 3:45. The lab starts at 3:45. Goes to 5:45. So I'm off campus then around 6 again. Tuesday and Thursday. Not many office hours, just a little bit in the middle and early on Monday, Wednesday. Fridays, when I don't have a treatment and they're not calling meetings, they love calling meetings on Fridays. Okay, but on the Birmingham campus, the academic building, it's the B building, the 122. If you don't know where that is or what that is, if you find the B building, it's called the academic building. It's in the middle of that quad over there. Ask for Dr. Pruitt's office. Everybody knows where that is. When you walk in, he has a suite of offices. When you walk in, his secretary's desk is right in front of you. Behind her is a copy room. That's where my office is on Friday. His is the big corner office. I'm not in there. And so that's where I'm B122. I don't usually really formally do a lunch on Friday, but I usually have a snack or something. Yeah, starting around 11, but I'm off campus by, well, no, I'm not. I'm usually on campus later than that, but I can't put that. Basically, I've got more than my 40 hours in the first 4 days of the week, but technically I'm supposed to be here at least 4 hours on Friday. So I put it down, but most of the time I'm here past then. I'm a glutton for punishment. Okay, any questions on where I am, when I am, whatever? Okay, enough of that. I think we're through with that. So now, okay. Oh, we made pretty good time on that. Let me get rid of this. Oh, one other thing we got to do. Don't have slides on this one. I feel like it's necessary to talk right at the beginning of the term about safety. Okay, now we're not going to do anything that you have to be worried about. There's no lab. You're not going to be operating electrical equipment. Not that kind of safety, but the basic safety stuff like, this is spring, right? Weather. If the alarm goes off, you hear that going off, what do we do in case of a weather emergency? Well, the idea is go interior and lowest level. Guess what? We're on the lowest level now, but we're not interior. Do not stay in this classroom, okay? Things, limbs from trees could come flying through the windows. You don't want to be here. So what do? We go out basically into the hallway, okay? That's the safest area. The secretary said she feels like that first stairwell you see, you can actually get under the stairwell. That might be a little bit safer. But you see, you can't go across the hall because those are windows. Yeah, everything's external except the hallway. Now, the restrooms, I don't think have windows. They may not be too bad because they're really the greatest strength is where you have walls that are close together. The halls are relatively close. The restrooms are even closer. And you got a lot of corner in the restrooms. You don't have many corners in the hallway. And don't go down this way because there's glass doors there. Or go back this way where you can't see out. Okay, that's the thing. Interior, lowest level. We're on the lowest level. Now, when you do go out, don't say, oh boy, I got to go home and get the dog out. Don't. The worst thing you can do, one of the worst things you can do in inclement weather is be on the roads. Those cars are not safe. Okay, so stay here. Because now, all of you look pretty able-bodied right now, but if any of you have some physical problems later in the term, I'm going to make sure you get out in the hall. It's pretty close, so it's not a hard thing to do. And then, but when I go out, I'm also going to carry my roll book, and I'm going to check the roll. I got to account for you. If I can't account for you, then people have to go back in the classrooms, restrooms, or other places, trying to find you, risking their safety because you took off and went somewhere you weren't supposed to. So please don't. Stay together in the hall, and we'll hear. The other good thing about the hall, I'm pretty sure it has emergency lighting, whereas the classrooms, the stairwells, they do not. I don't think. The stairwells might. Okay. Restrooms probably do not. So that's the downside on restrooms. So there's one type of emergency, exterior emergency, weather. What's another kind? Something inside, like a fire. Yes, okay? Now, let's just say I hope it won't happen. My computer decides to spontaneously combust here, okay? And it starts, we get a fire. What do we do then? Okay, yes, we'll go outside and let the rest of the building burn down, and we're safe though, because we're outside, right? Oh, maybe we should do something first. What might we do? Oh, pull a fire alarm. Well, let's see. I'm new to this building. Let's see where the closest fire alarm is. There's one right there, okay? Right within sight of the doorway here. Okay, you see it over there? So someone runs out there and pulls the fire alarm. Then you go out the building. But we also should do something else. Yes, 911. Even better than 911 would be calling campus police. But the number I have is one for Bessemer, okay? Sorry, I forgot that. I do have the number of the phone that the Bessemer police always had. The duty person on call has it on his body, his or her body, all the time. I don't know the one they have for the site, so 911 will have to do, okay? Be better if you could call campus police. They'll get in touch with 911. You call them, we'll apologize later, okay? Now, so those are two things we do before we go outside. Now, where do we go? And how do we get there? Well, we're really in an ideal situation. Go out this door here, and unless the fire, if the alarm went off and we were leaving and the fire's this way, then we go that way. But without it, we go this way. Take a left and go out the door that you probably came in. They're just right there, okay? And we go as a group. Again, I'll be the last one out of the room, make sure everybody got out and no one's injured or anything. And we go to the parking lot. My orientation is not good here. It's the parking lot right across the way there. It's across that street that sort of makes a loop of the East Campus here, the parking lot right across there, okay? We go together, we stay together. We don't say, oh, fire, no more school tonight, I'm heading home. No, don't do that, because I'm going to be the last one out. I carry my book, I call roll, we can't find you. The logical assumption, they're still in the building, so someone goes back into the burning building, risking life and limb to try to find you when you took off and left when you weren't supposed to. So don't do that. Stay together, you'll get word. Hey, that's it for tonight. Or, hey, it was just a computer fire. It's all over with. There's another room you can go to. Yeah, we'd like that with me. Okay. Now that also would be the same type thing you do if there's a chemical spill somewhere in the building and the alarm goes off, we head out, same deal. But don't leave until we all are accounted for. All right, one more safety issue, unfortunately, we have to talk about. Does Parkland ring a bell? Active shooter. I never even used to think about active shooter. Nowadays, you've got to. And actually, I was talking to Dr. Marable before the class began. I said, she was saying, yeah, the hall is where you go for fire emergency, for weather emergency, and the parking lot is where we go for fire emergency. I said, Dr. Marable, what do we do about active shooters? She went, I guess just barricade the door. I said, Dr. Marable, the door opens outward. And so we are not good at shame, okay? I think maybe we should try to get out of the windows, okay? We're all on the first floor. It's not a far pitch. Get those screens out of there. Get the window open as wide as possible. Get down and get out. Unless, of course, if shooting's coming from outside, then we stay in here. We get down out of sight, below the window level, okay? Now, here's what else we do, or I do. Y'all are valuable. I'm 67 years old. My life is mostly spent. You get out, I'll deal with the shooter. If it comes to that, you are the future, I'm the past. Okay? So don't mess around, don't be a hero. I will. No. Active shooter, y'all got to get out of here. If we could lock the door, we work. There's no way to lock the door. So I may be down here
Why
holding
don't they
the
put
door.
locks on the door? Tell them to be some locks.
Yeah. Maybe they'll think about it and get something done, but for now, y'all get out. Okay? As long as
Your wife will say you come with us too.
What's that?
As if your wife will say.
Oh, she knows we got insurance. No, I mean, okay. No, she'd be mad too, but no.
Yes, she would.
Yeah. All right. But I'll be the last one out then. We'll just put it that way. Okay. Those are the safety issues. Any questions? The classroom I have over there, there's a whole series of things. I can lock the door from the outside, all that. This doesn't even have a lock. I mean, so anyway. What's that? Oh, okay. Let me then, so we do have, I got through that faster than I thought I would. I'm usually way too slow. Usually we talk about research paper. We don't have that. I know y'all are boo-hissing on that, but now let's get to, see, this is the only one I'll normally have because I just had my syllabus on that old one. Okay. All right. I've already been there once, but all right, let's get started with chapter 5. All right. And these are fairly short chapters, so we might be able to get more covered than what I was thinking. Okay. All right. Now, I've been trying to figure out from the cover and stuff, is that the Golden Gate Bridge? It sure looks like it could be. I've been in San Francisco, and the landscape looks right, but I just don't remember. I think it has to be. But anyway, pretty nice picture. Okay, chapter 5 is dealing with forces. Does anyone know just a general definition for what a force is? When I took physical science in high school, 9th grade, I had the football coach as the teacher. His name was Pooley Hubert. He had played at Alabama, and he was either on the throwing end or the receiving end of the longest pass in Rose Bowl history for the University of Alabama. And he coached like he still was from university. He had to have been way before Bear Bryant, but he talked just like Bear Bryant. You know, like he had rocks in his mouth. And he was a terror. He was a terror as a coach, and he was a terror as a teacher. Nobody messed with Pooley Hubert. But I remember him saying, a force is a push or a pull. That works for me. And really, that's not a bad definition. A push or a pull. There's a guy pushing on, what is that? I don't know what. Pushing force, and yet why he's having the strain is that there's a frictional force that's resisting his push. Okay? And if he is, here's something we'll get to a little bit later. No, we may not get to, so I'll go and say it now. If his force is in that direction with that much, and the resistive force is that direction, is it moving? It may not be moving, or if it is moving, it's moving at a constant speed. Okay? Because the net force is going to produce an acceleration. And since this speed, this force is the same as that force, or at least it looks like it is to me, then there's no net force on the thing. So it's either at zero velocity, which is a constant speed, or it's at a constant velocity. So that's what you can tell about forces, just that illustration. Okay? I'm sure that's not what they meant here, but that certainly is true. Now, sure, he's pushing against the friction of the driveway, pavement, whatever that is there. Okay? But he's also pushing against something else. I don't know what this is. It almost looks like it's a chunk of concrete. If it is, it's not moving. Okay, I don't think. Okay, but if that's just some box or something like that, I just can't tell. Whatever he's pushing against something we call its inertia. Anyone know what inertia means? What are the first 5 letters of inertia? Okay. First 5 letters. What does that spell? Can't read my writing. You're making fun of me, I can tell. What's the first 5 letters? Inert. What does that mean to you? What I like to do be on Saturday afternoon. Totally inert. Okay, no, not me. No, that's part of inertia, but that's not all of inertia. Inertia means maintaining its state of motion. Or not. Okay? If it's at rest, it's staying at rest. Or if it's moving, it's tending to keep moving. Inertia is both wanting to keep moving or wanting to stay at rest. Someone throws a bowling ball at you. You have to stop it. You'll find out it has a lot of inertia because it wants to keep on moving. Okay. Ping pong ball, you don't care too much. Okay. Back that away. So inertia is related to the mass of an object. If that's a concrete block, push all he wants. He's not going to move one that big. But if that's just a box of some nature, or maybe looks like it could be the back of a painting or picture or something, yeah, then there's no sweat. But it looks like it's a little bit more than that. So force is also related to inertia. And in fact, what I just quoted for you is Newton's first law of motion. That an object tends to maintain its state of motion, whatever it is, unless it's acted on by an outside or unbalanced force. Okay? So if indeed these 2 forces are the same, his push is exactly the same as the frictional resistance, then it's going to maintain whatever is motion. If it's sitting at rest, it's going to stay at rest. Or if it is moving, it's going to move at a constant velocity with no acceleration. That's what Newton's first law is. Okay. This, and again, you'll get sick of hearing me say this. Boy, this is one lousy PowerPoint show. There's a lot. That was on page, the first figure was on page 124. This next figure is on page 130. They are skipping an awful lot. When I was trying to find these PowerPoints, and this publisher, Pearson, has one of the worst websites for a big company that I can imagine. It's as slow as glacially slow, okay? And all I could find was what they called the image PowerPoints. I wanted the teaching PowerPoints. I could not find them anywhere. I could not see that they even existed. So I guess I'm just going to have to do a lot of fill in the blanks here, okay? I can't really write too much on that one. I'm going to write on this one. We're not anywhere close to that slide, okay? So, Newton's first law of motion, I just gave it to you. An object maintains its state of motion or rest unless it's acted on by an unbalanced force. Okay? That's the first law. The second law, and that is on page 125, if any of you have a text, and that's open. It's the law of acceleration. Now, they do have some pretty interesting things here. It's not a bad text. And by the way, I didn't choose this one. Dr. Marable went out and checked to see what other schools that were teaching this program. There's only like 1 other or 2 other in the state. And she found they were using this one and they liked it, so I went for it. But then I found out they were in the 10th edition and this is the 11th. I don't think that's what your email was about. but there are some inertial tricks, and you may have seen these before. Have you ever seen the little parlor game? Not quite a parlor game, more like a dining room game. You have a place sitting on a tablecloth, and someone just takes the tablecloth and yanks it real fast. Guess what? The setting stays pretty much where it was. I wouldn't try this with my finest crystal in China, but try it with plastic stuff, or something like that. Yank on it, and sure enough, everything pretty much stays in place. An object tends to maintain its inertia, its state of movement or state of rest, unless that's operated on by unbalanced force. Let's see if I can do something similar here. Possibly. Here's pen on paper. Yank the paper, the pen stays right where it is. Maintains its state of motion. Whereas if I throw the pencil at you, unless you exert a force to stop it, it's going to hit you, right? And we won't do that, though. I could get sued. Okay, so that's the first law. Okay, and in your text it says, try this activity, inertial tricks. That's what it's talking about. So the second law of motion, okay, first law said, unless it's acted on by an unbalanced force, right? Then it maintains its state of motion, either at rest or in motion. It's constant velocity, constant direction. Okay? Oh, let me just mention this one too. I don't know if you really need to know it. When I say constant state of motion, I say constant velocity. Do y'all know what I mean by velocity? This is a physics word, okay? In regular everyday English, speed and velocity, we use them interchangeably, right? In physics, they're not interchangeable. Speed is how fast something's going. That's only a magnitude. By the way, it's never negative. We don't talk about you're traveling at a negative speed. You're traveling at some speed. Whereas velocity is what they call a vector quantity. You want to know what vector implies? A vector is sometimes called a directed line segment. Okay? And a directed line segment indicates a direction as well as a magnitude. So speed is just a magnitude. We call that a scalar quantity. Speed, scalar, vector, velocity. Okay? Velocity, vector. Okay? Whereas a vector quantity has a direction implied with it. So when I say a constant velocity, that just doesn't mean a constant speed. I may be traveling at constant speed like this, That's at the same speed. I haven't changed my speed, have I? But I've changed direction like crazy, so my velocity is anything but constant, okay? Because you're changing direction. So when we say first law maintains its motion, that implies speed, velocity, not speed. So its motion would be straight line, constant speed. Okay? Now, the second law. What if you did have a net force? And that's what I was talking about before. If one of those forces was stronger than the other force, let's go back to this one. If this force was greater than this force, say either this was less or that was greater, then it's going to move. It's got to move, okay, because the net force is in that direction. But if the force was greater, that means it's going to accelerate. Not at a constant speed. That's why I said these can be equal, but if it's in motion, it's going to be at a constant speed. Okay? No change of direction, but constant speed. But if it's at rest, it's going to stay at rest if they're equal. Okay? But if one is greater, if the net force is greater, then it's going to accelerate. Not just go at a speed, it's going to accelerate. Okay? And what does accelerate mean? Change of velocity. Now, that's accelerating for sure. And that's a deceleration, going backward, but it's still an acceleration. But that's also an acceleration because I'm changing my velocity from here to there to there. Okay? So that's a change of velocity. So you have any kind of change of velocity, not speed. Velocity is an acceleration. We don't usually think of it that way. So what is the second law? If there is a net force acting on an object, now this doesn't show that there is, but if there is a net force acting on an object, it's going to accelerate. Got to accelerate. Now, I bet you, most of you have seen this expression before. F equal ma. Have you? Force, and this force is a net force. If an object has a net force on it, it's going to have an acceleration. And the net force is proportional to the acceleration, meaning if the acceleration is big, net force is going to be big. If the acceleration is small, the net force will be reduced anyway, okay, for a constant mass, okay? Now, and that's a net force. Now, this is almost going back to the previous case, but I want you to imagine something. Let's imagine you're in a jet aircraft flying at 500 miles per hour. Straight level flight, 500 miles per hour. What's the net force on that plane? Is there any net force on the plane? What you think? Moving at 500 miles per hour, is there a net force on the plane? Yes. There are forces on the plane. Sure, it's spitting out, it's a jet, so it's spitting out the exhaust out of the back, and that gives it thrust forward. But guess what? It's going 500 miles per hour. You ever driven down the road? I used to do this when I was a kid. I don't do it anymore. I like doing, I was in the car, sticking my hand out the window, you know, feel the faster we're going, I almost can yank your arm off. Somehow that's fun. I don't know. Okay, so if you're going 500 miles an hour, a lot of air resistance. Okay? Now, if you're going at a constant 500 miles per hour, straight line, level flight, you're not accelerating. That's constant speed. And a change of velocity is what makes an acceleration. So guess what? No acceleration there. No net forces. Sure, the exhaust is pushing you this way, but the air resistance is retarding you, just like that previous picture was. What's more, gravity is pulling down, right? A jet plane full of people, it weighs a lot. But, has anyone ever heard, this is not what we should be talking about now, but it's fun. If I were to hold this piece of paper and blow under it, anyone want to predict what's going to happen? You're absolutely right. The paper comes up. Now, what if I hold this piece of paper and blow over the top of it? What's going to happen? It comes up. What is going on there? The paper just wants to come up all the time. No. What it is, that demonstrated a has nothing to do, well, it has a little to do with what we're talking about. It's called Bernoulli's force, or Bernoulli's principle. That the velocity, and we're going to do this later, in a later chapter. I'm trying to think, it's probably the one that does the matter, that chapter. Okay? And it's called Bernoulli's principle, that the faster a fluid flows. Now, a fluid is not just a liquid. It's either a liquid or a gas. Air is a fluid. Water is a fluid. Blood is a fluid. Okay? All these things are fluids. Okay? The faster a fluid flows, the more the pressure is reduced. Now, are all of you medical professionals of some type already, or are you just getting into it? When do most strokes occur? Do you know? Second? It's 6 years old. Strokes.
Your blood pressure's high.
When your blood pressure is high. And when do they occur? Time of day, usually. You know?
In the morning.
In the mornings. Usually in their sleep. Why? Because blood flow is slower, the pressure is increased. You're absolutely right. High blood pressure. Now, you think of it as when you're excited or, but yeah, that's not necessarily. It can be. If you're pumping against a clogged artery, that's going to increase the pressure too, and that will cause a stroke. But most of the strokes, someone will wake up having, maybe not wake up, having suffered one in their sleep, because the velocity of the blood slows down and the pressure goes up. And the greater blood pressure, there's a weakness somewhere in the arteries, or something there, and then that's basically a stroke, right? A rupture, and that does occur. Okay, so the whole reason I went into that is because if you notice the shape of an airplane wing, it's like this, right? Meaning that the air going over the top of the wing, the air is just sitting there. The wing hits it, the air going over the top, and then the air at the bottom gets to the bottom. It slows down. This has to speed up, right? That provides lift to the plane. That's why the planes get on that long runway and gun those engines and go as fast as they can. And when they go fast enough, and that lift, the air velocity over the top is enough that it provides lift. So gravity is pulling downward. Bernoulli's principle is pulling up. So it's long, and they're balancing. If they're going in straight, level flight, constant 500 miles per hour, net force is 0. Forces on the plane are huge, but the net force, everyone is balanced by another force in the opposite direction. So that's what Newton's second law says. If you have a net force on it, it's going to accelerate. Or if it's accelerating, it's got to be a net force somewhere. That's Newton's second law. Basically summarized in that little expression there. Net force is equal to mass times acceleration. Okay. Now, there's a couple of ways we can do with this, and anytime you have a mathematical expression such as this, one thing's equal to the product or a quotient of the other two, you can turn this into two other equations. Divide both sides of this by mass, okay, and you have acceleration is equal to the net force over the mass, okay. What is that telling you? The acceleration is directly proportional to the force, net force, but inversely proportional to the mass. What does that mean? As the mass goes up, the acceleration goes down. Of course it does, okay, for a constant net force. Or if the mass is going down, typically your acceleration is going to go up for a constant force. Or we could have multiplied, let's go back to the original, F net force is equal to mass times acceleration. This time divide by acceleration, and you get mass is equal to the net force divided by acceleration. We don't use that one this much, but you could. Now, we're going to run into formulas like this all over physics. My boy, electricity has them out of the ears this way. And here's one way. When I was in the Navy and went through some of the Navy schools, they had this little device, and you can use it or not depending on which you want. And some like triangles. I prefer the triangles. It's a pretty ugly triangle, okay? The horizontal line is a dividing line, and the vertical line is a multiplication line. Other people like circles, and you can do it that way. Split the circle in half and split the bottom in half too. That's a dividing line. That's a multiplication line. Put the letter that stands by itself, like net force here, and then put mass times acceleration here. You can do it over here too. Net force, mass times acceleration. It's just what shape you like better, okay? And if you're looking for mass, then that's net force divided by acceleration. If you're looking for acceleration, that is net force divided by mass. Or if you're looking for net force, it's mass times acceleration, where we started. And you can use that little device anytime you have a multiplicative relationship like this. 3 entities, okay, 2 multiplied or 2 are divided. Then, yeah, you can use those symbols and help yourself solve problems that way. Okay. I thought we'd do that while we're here. Now, let's talk just a little bit about units, okay? Y'all are all medical, right? You said? What units do you typically use? Just let me know. Whatever you're dealing with. What are some units you use in your...
Milligrams.
Say again?
Milligrams.
Okay, you use milligrams. That is an SI unit. What does that mean? System International. Metric, right? Gram is a metric unit. What does gram measure or milligram measure?
Weight.
Okay, not quite. It measures mass. Okay. And now, I can hear arguments coming up already. When you go to the grocery store and you see those big scales there and the pan underneath it and you're wanting to weigh your bananas or your peas or carrots or corn or whatever you're weighing that you're buying per pound, okay? Pound and the scale, the outer scale usually is in pounds, maybe ounces, depending on the size of the scale. That's a measure of force or weight, okay? But on the inside, they have the same scale, a different scale, and it'll be in kilograms. You know, if it's pounds and kilograms or ounces or milligrams, okay? The outer scale is measuring force or weight. The inner scale is measuring mass, okay? Why can we use the same device to measure both of those if they're not the same things? Because on the surface of the Earth, which is where we live most of the time, right? Weight is equal to mass times the acceleration of gravity. And see, weight would be, say, in pounds. No, we'll get back to that in a minute. Mass would be your kilograms, and G is the acceleration of gravity, due to gravity. And that's the same everywhere on the surface of the Earth, or even anywhere near the surface of the Earth. G is a constant. In the metric system, SI system, 9.8 meters per second squared. It's an acceleration measurement. Because this formula right here, that's a weight or a force. There's a mass. That's an acceleration. Force, mass, acceleration. It's the same kind of formula. And you can use these same triangles or circles on them, okay? And that's why we can use the same scale, because they only differ on the surface of the Earth, when we're talking about weight, by a constant. The constant has units. That's why they're not the same thing. That's an acceleration. Meters per second square, feet per second square. So those are not. One's a mass, the other's a weight. But they're equivalent to each other because that's a constant in between. If you went to the moon, is your weight the same? No, much less weight. Go into deep space, you're almost weightless, okay? But your mass is the same, right? So it depends on what your acceleration due to gravity, your gravitational force is, or acceleration is. Okay. Got way off there. Okay, now let's talk units. Okay? You mentioned milligrams. Let's just bump that up to, really bump it up. You're measuring my mass. You're not going to use milligrams on me, I'll tell you that. The number will be huge. Okay? You'll use kilograms. And my acceleration due to gravity is in meters per second squared. And a kilogram meter per second squared, the force unit or the weight unit that corresponds to that is a Newton. Named after good old Sir Isaac. Yes. Okay. Now, any of you use other units? You said weight. Ounces or pounds. Okay. Let's go with pounds. That is a weight. And that would be some mass times acceleration due to gravity in the U.S. customary or British or English, however you want to call it, is 32 feet per second squared. Now, I don't think you need to know that for the course. Maybe you need to know it for some of the problems. What is the mass unit in our everyday English units? We never talk about mass. Not in the U.S. customary system. Never. or definitely hardly ever, we talk about weight. We don't talk about mass. If I were to say the unit right now, you probably hardly believe me because you never use it. It's a slug. I'm not kidding. S-L-U-G, slug. You thought that was those slimy things that eat at your plants, in your garden? Those are slugs too, but this is a different slug. The unit here is slug. Okay? Now notice, pounds you can abbreviate it LB, feet you can abbreviate FT, seconds you abbreviate S. There is no abbreviation for slug. No one uses it, so if you ever use it, you have to write out the word. It doesn't even have an abbreviation. So we hardly use mass. We should, but we don't in the U.S. customary or the English, whatever system you want to call it. But 1 pound would be a slug foot per second squared. Okay? That's what a pound is. Okay. I was writing how many pounds that was with the acceleration due to gravity. All right, so that gets us down to example 1. So if it's all right, I'm going to erase what we've done so far. Okay. Example 1. What force is necessary to produce an acceleration? Now, this is not the acceleration due to gravity. To produce an acceleration of 6.00 meters per second squared. Now, we might need a little time out here because this is chapter 5. The first 4 chapters talked about things like motion and things like this, and you would have had a better understanding what I'm talking about when I say this is an acceleration. Okay? Now, let's move back a little bit. Let's think about motion. For motion to occur, I have to start here and end up somewhere else, right? Now, what two quantities are involved with me moving from there to there?
Distance.
A distance, for sure. Now, unless this is Star Trek and I say, beam me up, Scotty, y'all don't remember that. Even that took some length of time, right? So the other thing is time. So a change of position, that's measured in a distance. And by the way, I didn't ask, do any of you have a class of 6? Okay, you don't. Okay. Dr. Merrill said go 4 to 6. I thought, well, do they have any classes after? I don't know. You can let them go early if they do. Yeah. So I wanted to know that. So you have a change of position. We call that one of 2 things. Distance. Okay, you're used to that word, right? You said it out there. Distance. That is a scalar quantity. There's no direction involved with distance. Displacement, on the other hand, has a direction with it. Not only is it how far I went, but what direction I went. So there's a scalar, just a magnitude only, or a vector magnitude with this direction. Magnitude, I can't talk this late at night. Okay. It's the drug. No. All right. So we have that. Then when you put time in it, and you say, how long did it take to go there? We have distance divided by time. What does that give us? Meters per second. Miles per hour. What does that measure? In your car. What do you measure in miles per hour? Speed, of course. Your speedometer tells you that, okay? So, the same in physics. The scalar quantity is called speed. Velocity would be miles per hour, or feet per second, or meters per second, or centimeters per second, or furlongs per fortnight, or whatever. Distance divided by time, that would be a velocity if it has a direction, a speed if it doesn't. Okay? So, that's a change of displacement per change of time. See, physics just loves to do this. If you have one quantity, take the time rate of change of it and see what it is. You have a distance or a displacement, divide it by the time it took, and you've got a new quantity, velocity or speed. Well, we got velocity. So, if I go a very slow velocity to get to that displacement, it takes me a long time, doesn't it? or same change of displacement, but a definite change of velocity over a smaller time. What would that be called? Think of your car. Say again? Say again? Did someone say something?
She said acceleration.
Acceleration. I'm hard of hearing. Remember, I can't hear well. That's an acceleration. You got a velocity here. Let's take a time rate of change. Change of velocity over change of time. I went from 50 miles per hour driving up the ramp to 70 miles per hour when I got on the expressway. Okay? That's an increase of velocity of 20 miles per hour in however many seconds it took. People are talking about their really hot cars. Taught a bunch of automotive students physical science yesterday. I said, what do you use to tell how good your car is? You know, they said 0 to 60 in 4.3 seconds. Yeah, it's exactly 0 to 60 is 0 miles per hour to 60 miles per hour. Change of velocity in a time interval, 4.7 seconds or something like that. They were probably exaggerating theirs, but anyway, that's an acceleration. Change of velocity over change of time. Now look at what we've got here. Velocity would be meters per second. And that's what we can either call it meters per second. That just takes so long to say. What we abbreviate that to is meters per second squared, because both of the seconds are in the denominator. Okay, so we call it meters per second squared. There's no such thing as a square second, so don't even try to get one. But that's what it means. Meters per second squared. So that's an acceleration. Boy, that took forever to do, didn't it? Okay. What force is necessary to produce an acceleration of 6.00? Oh, let's time out there too. Why in the world did I write that, and did they write that, 6.00 meters per second? Isn't that 6 meters per second? In physics? Yes, but not quite. This means it's precisely 6.00 meters per second, not 6.01 or 5.99, 6.00. Correct to the nearest hundredth of a meters per second squared. Okay? If I said 6 meters per second squared, that could have been a 5.8 or a 6.3. You know, we rounded to 6. Okay? This says it's 6.00, good to the nearest hundredth of a unit. 6.0. Okay, so that's why we did that. And we'll see why in a minute. Okay? What is the force necessary to produce an acceleration of 6.00 meters per second on a mass of 5.00 kilograms? Boy, they really are big into their units here. Okay? Very precise, 5 kilograms. Okay? What force is necessary? So we're looking for actually a net force. What is the relationship between net force, mass, and acceleration? I think I've already erased it, but I had it on the slide a little while ago. What was that? Equal mass times acceleration. So just take them and multiply them. 5.00 kilograms times 6.00 meters per second squared, and you get 30, now catch this folks, 0.0. You can either call that a kilogram meter per second squared, or you could call that 30.0 newtons, because that's what a kilogram meter per second squared. Excuse me, I got hiccups. Okay? That's your net force. Okay? Now, notice what happened. We had 3 significant digits here, 3 significant digits there. When we multiply them together, you don't have that second 0 here, because then that would be implying you had 4 significant digits. And there's something you can't do. You can't get more precision out than what you put in. 3 significant digits, 3, that's why I rounded this to 30.0. Not just 30, 30.0 indicating 3 significant digits. It's kind of like the old computer programming adage. You probably heard it before. Garbage in, garbage out. Okay, have you ever heard that? If you put in bad data, you're going to get bad information out. Put in good data, hopefully you get good if your program's right, okay? Well, you can't get out more precision than you put in. Now, if one of these was only 2, then you could only have 2 coming out. Okay. So your answer is no more precise than the least precise part of your input. Don't sweat it. It's not a big deal, but this is physics. We talk about it. Okay. Newton is a kilogram meter per second squared. Okay. How are we doing? Oh, no! Just when we're beginning to have fun. Well, we're always having fun. We've run out of time. Okay? So we'll start next time on example 2, and I'll try to pick up the pace a little bit. We won't have all the syllabus and that kind of stuff to do. We'll just go through, sort of lickety split it here. Okay, does anyone know anyone else who's in the course, or are y'all all brand new at this too? Okay, if you do know, let them know we're down in 103 now, not up in whatever we were in before. And I like this room better. That other one's such a big room for fewer than 10 people. So, all right, if you want to start working on a few problems, there are some problems at the bottom of page 127 where we left off. You can try to work some of those. When they go on to the next page too. But don't do any beyond what we did, and we didn't do much, so not a lot to do. Any questions? Okay, what was your email about? Sorry, I didn't get to see it.
I was trying to see if this class was canceled because my other class was like canceled and I had to reschedule.
Oh, it was? Was it had to do with this program?
I was in an anatomy class.
I see.
And then it got moved to Saturday and yada, yada, yada. So there's like always check to see.
Okay. I don't know the answer to that yet. Were you in here when Dr. Marable came in and said, I sent you an email, read it? I'm guessing that's going to let me know whether but she didn't say the class is canceled, so I'm figuring it's going to make it. I'm guessing. But it may be that they're going to say if no more people show up on Wednesday, we're going to have to cancel. I don't know. But we'll see. I'll see what it is right now. All right, I'm going to end the recording.